Hey, I have Wyatt's test here, so I'm going to take some time and go through some of the questions that he missed. The biggest piece is that he's got that formula sheet that's taped in his math notebook. It's somewhere right after lesson 8.4, but I can't remember what page number that's on. So it was between lessons 8.4 and 8.5 in his math notebook, and it has 5 or 6 formulas that they were able to use on this test. Okay, so the first question asks which name best describes the angle pair. He selected vertical angles, but vertical angles are formed by intersecting lines. So remember that, for example, these two angles here would be vertical, and then these two angles on the left and right would also be vertical, and that's not what we have here in this picture. So if you add those two numbers together, 119 plus 61, that is 180, and when two angles equal 180, they are supplementary angles. He got questions 2 and 3 correct, and so I'm going to skip over to 4. This says just to circle yes or no to indicate whether each set of lengths could form a triangle. So in that lesson, what we were looking at is adding two of the two shortest side lengths together and making sure that they were bigger than the third side. So if I look at letter A, for A, it's 2, 3, and 4. And if we add 2 plus 3, that's 5, and 5 is bigger than 4, so yes, this would make a triangle. In letter B, if I add 3 plus 6 together, again, I'm picking the two shortest sides always, that's 9. 9 is not greater than 14, it's less than 14, so that one should be no. And then in letter C, 4 plus 8 is 12. 12 is greater than 9, so that one does work again, so that's going to be yes. So again, we add the two shortest sides together and see if that's greater than the third side. Okay, in example 5, it's talking about area of a triangle, so the first thing we need to do is make sure we can access or know the formula for area of a triangle. So the formula is 1/2 times the base times the height. It says which of the following could be the length of the base and the height of the triangle? Circle all that apply. Okay, sorry, I don't know what I had to pause the video real quick. But anyway, so we're trying to figure out which of these will work and could be the possible lengths and base of the triangle, or excuse me, length of the base and the height of the triangle, and then circle all the ones that work. So you're basically doing this formula 5 different times. So on letter A, I'm just going to kind of talk through this. 12 times 4 is 48, and then I would take half of that and get 24. So that doesn't work because it's looking for an area of 30. 10 times 3 is 30, but the formula has 1/2 in it, so I have to cut 30 in half. I get 15. That one doesn't work. Letter B, 10 times 6 is 60. Half of 60 is 30, so that one does work. Letter D, he did have correct. Again, 10 times 6 is 60. Half of 60 is 30. And then in letter E, 5 times 12 is 60, and half of 60 is 30. So you should have circled C, D, and E. Number 6 just asks for the area of the trapezoid. So again, we want to make sure we're looking at that formula sheet. Area of a trapezoid is found by doing 1/2 times the sum of the two bases times the height. So it looks like in his work what he did was he just multiplied all three numbers together, but we want to take 1/2 of 10 plus 6 and then multiply that by the height, which is 4. So 10 plus 6 is 16, half of 16 is 8, 8 times 4 is 32. 7, 8, 9 are all about circles. You're going to notice a little bit later on in the test some comments that I make about circles in his work. So something that I think can be fixed pretty easily if he can remember tomorrow when he retakes the test. So number 7 is about the interior angles of a circle. So if we start here and we move around clockwise, how many degrees is that? And it's 360 degrees all the way around the inside of a circle. So if we know two angles that are formed inside, can we find this third one over here labeled X? And we can. So essentially we just set up an equation and we add all the three pieces there that we know. x 105 and 45, and we set it equal to 360. So some of what we do in this unit with formulas is solving equations, and so that's why we did that unit with equations just before this. But 105 plus 145 is 250. So I'm just kind of combining those two numbers there. And then we want to do the opposite of addition. We want to subtract 250 from 360, and that's going to give us 110. So that unknown angle measure there has to be 110 degrees because, again, all three of those angles have to add up to 360. He got number 8 correct. Number 9 is asking for the area of the shaded region, which means just kind of the outside of that square where the circle is not. So what we talk about in these cases, this is our area of composite figures lesson, where we want to calculate the area of the rectangle, but then we want to subtract out the area of the circle. What he did on his, or what he answered, is just the area of the square. 12 times 12 is 144, but he did not subtract out that circle in the middle. So again, area of a rectangle is length times width. The area of a circle is pi r squared. So I'm just going to be plugging numbers into this formula and then simplifying. So again, 12 times 12, we use whoops, that should be a minus sign. We use 3.14 for pi. And the radius of this circle, so because the side length of the square is 12, that means that the diameter is 12. And if we cut the diameter in half, we get the radius. So again, that's 12. And so then half of that would be 6. So when we plug 6 in down here, because that's the radius and we have to square it. So I'm just going to grab a calculator. Again, 12 times 12 is 144. 3.14 times 6 times 6, because when you square a number that's 6 times 6, is 113.04. And when you subtract 144 and 113.04, you get 30.96, which is letter B. And then I think when I scanned this in the wrong order, so I got to skip way down here. Yeah. Okay, question 1 says that the measure of an angle is 144. What's the measure of its supplement? He wrote 180 here, so I know he's recognizing that supplement does mean that angles equal 180, but we're talking about two angles together. One of them is 140, and what is the other one if they are supplements? Which means if we don't know one angle and the other one's 140, they need to add up to 180. So essentially we're subtracting 140 from 180, and we should have gotten 40 degrees here. I'm going to go a little fast. I hope not too fast. I'm trying to actually squeeze this in before I head over to the grocery store. But for 2 and 3, he just didn't have the setup correct. So on number 2, I'm not sure if he was adding them together or multiplying. It looks like maybe he was trying to set it equal to 180. I think that looks like a 180. Maybe it says 250. I'm not sure. But at any rate, these are vertical angles. Remember, if I go all the way back to that first example I did in the multiple choice, and I showed this picture here, vertical angles are across from each other. And when you have vertical angles, they're equal. So you should have set up 5x equals 50. Dividing both sides by 5, we find that x equals 10. And that's all we had to do here was just solve for x. In the third example, again, it looks like, I know my scanning's kind of bad. I see 80, 40 times 2 is 80, but here these two angles together form a right angle. That's what that box in the corner means. When two angles form a right angle, that means they're complementary. So we have supplementary and complementary. Complementary means they add up to 90. So I'm going to do exactly that. I'm going to add the two pieces together and set them equal to 90. Solving this two-step equation, this goes back to our last unit, subtracting 40 from both sides leaves me with 2x equals 50, and then when I divide both sides by 2, I get x equals 25. So that's what you were trying to solve there. 4 goes back to the multiple choice question that had 3 parts. I think it was number 4 for A, B, and C. It says he believes that these 3 side lengths form a triangle. Is he correct? And I think he's close here. He adds the two shortest side lengths together, says that it equals 21, but then they're not because it doesn't equal 20. It doesn't have to equal the third side. It has to be bigger than the third side. So 8 plus 13 is 21, but because 21 is greater than 20, then it does work. Question 5 says to find the complement of PQR using the diagram below. So complements mean they add up to 90. So if I knew what PQR was, I could subtract it from 90 to find its complement. But if you look at the picture, I don't actually know angle PQR. So this one took a couple of steps. First, students needed to recognize that this is a straight line, and all straight lines measure 180 degrees. So if I know this angle on the right, kind of underneath the line, is 129, I can take 180 minus 129, and that's going to give me 51. 51 is not the answer, though. 51 is what angle PQR equals. So again, if PQR is 51, now I can find its complement. So complement again means they add up to 90 degrees. So now I'm trying to find the number that when I add it to 51 gives me 90, or I can just take 90 minus 51 and get 39. So the answer here is 39. Again, you had to find PQR first before you could find its complement. The next problems are all about area. So needing to find, making sure you know what shape it is, find the formula on the formula sheet, and then apply the formula. So these problems are worth 3 points, and I tried really hard to give them some partial credit here. We gave a point for using the right formula. We gave a point for basically doing or showing some work, and then we give a point for the right answer. So on all of these, you're going to see -2. He doesn't use the right formula, doesn't get the right answer, but he does have some work down that I tried to follow. So the first shape is a parallelogram. So what I'm going to do is I'm going to write these formulas down on here, and then I'm going to go ahead and let's see, I could probably just give you the answers. I'll just be just as fast maybe to just calculate it. So here we go. The first one's a parallelogram, and parallelogram we do base times height. It's kind of like a rectangle, it's like slanted. So we don't do length times width anymore, we do base times height. This one should have been a simple 8 times 3. 8 times 3, it's 24. They do need units. Area is always squared, so 24 feet squared. 7 is a triangle. We talked about that formula earlier, 1/2 base times height. So, and really with multiplication, order doesn't matter. It doesn't matter if you call 3 the base or 10 the base. If I turn the triangle up on its side, 3 would technically be the base. I do try to keep it so that it matches the picture, but again, it's multiplication, so it's not going to be a really big deal. But 10 times 3 is 30. Half of 30 is 15. We should have gotten 15 meters squared. 8 is a trapezoid. We did one of those earlier in multiple choice. Again, it's 1/2 B1 plus B2. You're adding those two parallel sides together and then multiplying it by the height. So I'm trying not to write too much over his work, but I know you have his test so you can see that. So it's 1/2. The bases are 11 and 7. Again, doesn't matter which one goes where. And then we're going to multiply by the height, which is 4. So trying to do this in my head, let's see, 11 plus 7 is 18, half of 18 is 9, and 9 times 4 is 36. So we should have gotten 36 inches squared. The last one's a circle. We did an area of a circle above in multiple choice. It is pi r squared. We always have to look at the picture and make sure that we're given radius, which is halfway across the circle, and that we are here. So this one is pi, which we use 3.14. The radius is 2, and we have to square that. So 2 times 2 times 3.14. And that is 12.56. Again, our units, centimeters squared. So one thing I wanted to point out that I was noticing in his work throughout this portion of the test, and it was something I'd shared earlier that I would point out, but he's using pi everywhere with parallelogram, a triangle. I think maybe not here. I didn't see pi. So I'll pi there, which I should have. But we should only be using pi when we're working with circles. So like 6, 7, and 8 are not circles. The number pi should not even be on our radar. So make sure when you're working with him that we're discussing that kind of over and over again. Oh, this is a circle, we should have a formula with pi in it. This is not a circle, we should not be using a formula with pi. And he had his formula sheet, and I don't know if he lost it, if he's going to say he lost it, he doesn't have it, it fell out, I'm not sure. I tried to make sure everybody had it and was working with it. I don't remember that he didn't have it or said he didn't have it. If he can't find it in his math notebook, please let me know. I want to make sure he has it while he works on his retest. I do have on here, I've written the formulas you've needed for today. So if he can't locate it, you've at least got them on this video. Okay, the next two were the first, number 10, was actually worth 4 points, and 11 was back to 3. So on number 10, again, we have this concept of an area of composite figure. You can probably see on his test a little better that this part's all shaded in. And that's all you're supposed to find is the area of that shaded part. So what I want students to recognize first is what shapes do you even see? So my hope is that they see a rectangle and they see 2 circles. And the shaded portion of the rectangle would be calculating the area of the rectangle, but then subtracting out the area of both circles, so the 2 circles. What's kind of nice here is the circles are the same size, so we only have to calculate the area of 1 circle, and then we can just double it. So he does have the formula for the area of the rectangle. They did get a point for that. They got a point for showing area of the circles and doubling it. Then they got a point for subtracting the 2 numbers. So area of the rectangle again is length times width. I'm going to put the 2 out in front because I have 2 times pi r squared since there are 2 circles and they're the same size. Length times width here is going to be 6 times 12. And we're going to take 2 times 3.14 times the radius. So again, looking at, because this rectangle, I'm going to kind of erase some of this blue now so just you can see what I draw, but because this rectangle is 6 feet across, the circle is also 6 feet across, but if I just want the radius, that's going to be 3. So we're squaring 3. So I'm going to get, I wrote an equal sign there again. I'm going to get 2 numbers here and subtract them. And again, we're just grabbing a calculator. 6 times 12 is 72. And then in my calculator, 2 times 3.14 times 3 times 3. And that's 56.52. Now when I subtract 56.52 from 72, we get 15.48. And our units again for area are feet squared. So number 11, we have a circle, and we're just supposed to find in the shaded part. So we did one like this in class where 3/4 of the circle were shaded, and so we talked about how to find 3/4 of a number or 75% of something because we've worked with fractions and percents. And in this one, hopefully what students recognize with it, it's 25% of the circle or 1/4 of it that's shaded. So we're going to find the area of the circle and then find what 1/4 of that is. So we're using pi r squared because it's a circle, so 3.14. The radius is not given in this picture. We're given diameter. That's 16. That's all the way across. We got to cut that number in half and get 8, and 8 is the number that we're squaring. So to find the area of the circle, 3.14 times 8 is 200.96. So again, students got a point here for the right formula, a point for finding the area of the circle correctly, and then a point for taking 1/4 of it or dividing it by 4. You can do this a lot of different ways. You can multiply that number by 0.25 or you can divide it by 4. Both of those things will give you 1/4. So we're dividing it by 4. We just want to find 1/4 of it, and it's 50.24 units are squared, so centimeters squared. Okay, now I got to go back to that other page. I had 2 questions on it. There we go. The last 2. So these are just story problems. Making sure that when we read through a story problem, we can understand what it's asking and how to find it. Caden made a giant cookie for dessert. He wants to frost it. The cookie has a 20-inch diameter. How many square inches of frosting are needed. So there's a hint, square inches, that we're trying to find area, frosting the top of the circle, which frosting the top of the cookie, sorry, which is a circle. So area equals pi r squared again. So 3.14. We're told that this cookie has a 20-inch diameter again, but we need radius. So we have to cut 20 in half to get 10, and we're going to square that. 10 times 10 is 100. 100 times 3.14 is 314, and so that's the answer, 314 inches squared. 13 goes back to the lesson about circumference. So it says Victoria is designing a circular swimming pool area. The pool has a 30-foot radius, that is just halfway across. She wants to put tile all around the outside edge of the pool. So what we're trying to get students to understand is that outside edge of the pool, that is circumference. We're told how much the tiles cost per linear foot. How much will Victoria pay for the tiles? So if we find the circumference, we know how far it is around the outside edge of the pool. Then we can multiply that by 250 to figure out how much it's going to cost. Formula for circle is pi times diameter. So this is going to be 3.14. The diameter is going to be 60 here because the radius is 30. We have to double it. We don't square anything here. It's just 3.14 times d, which is, again, 60. So we get 188.4 feet for the circumference. Remember, circumference is, we don't square units in circumference, so it's just feet. So that's how long, or that's how far it is around the outside of the circle. That's the length of tile that we need. So now we're going to take 188.4 and multiply that by 250. If we have 188.4 feet around the outside edge of the pool, and it's $2.50 per linear foot, then we multiply that by 250 and we get $471. So again, looking through this test, in some spots I do see where he did kind of grasp the concept. He's got some work down there where, yep, that makes sense a little bit. Other times it's a little bit harder to follow. Students, they just see numbers in a problem and they think, oh, I'll just multiply those together, add them. We really just need to make sure that we're using that formula sheet in particular on that page that had the area. We actually canceled golf practice tomorrow. I don't know what track's plans are, but I would guess with the weather, the rain, the wind, they'll probably be inside. What I would like for him to do is to start this in my class in AL tomorrow, and then we can finish it after school, and I can write him a note, or I can let his track coaches know that he might be a little bit late because he's got to finish this test, but I know he can do better than this. So let me know if you have any other questions, and hopefully he's ready to go tomorrow. Thanks.